Good afternoon, and thank you for joining us for the webinar on schedule quality. This webinar has been brought to you by the APM's Planning, Monitoring and Control Specific Interest Group. We are fortunate to have Franco Pittoni joining us today. Franco will be giving us a technical webinar on schedule quality with a detailed analysis of the main metrics to use. This webinar will be recorded and will be available online. You will not be able to speak, but please do feel free to ask questions using your toolbar. We will pick them up at the end.
We would just like to do an understanding of who has been kind enough to join us on this webinar today. And if I could please ask you to vote on what best describes your current role now. The response to what best describes your role was that 16% are junior planners, 17% are senior planners, 6% are junior project controllers, 28% are senior project controllers, and 32% are project manager directors. I would now also like just to ask you quickly if you could let us know how familiar you are with the quantitative schedule quality assessment method or standard. And the results are that 8% are fully aware and feel comfortable with the method and standard. 43% feel that they are slightly aware, and 50% are not aware of it at all. I will now hand you over to the presenter, Franco Pittoni.
Good afternoon to everybody. So just as usual, a few words about myself. I am a mechanical engineer with some 15 or 17 years of experience in mechanical engineering as in building services, performed in design offices and sites, construction sites, testing and commissioning. So building services and anything that is not electrical and structural, if you want. That has been my first part of my professional career. Then I discovered project management, in particular planning and project controls, and from that point onwards I just kept studying it and doing this thing, and I'm still very passionate about it, and I still find it interesting and worthwhile dedicating my time and resources. In all my career I've always found the way in which information is dealt very, very important, and this has led me to becoming more and more interested in building information modeling and information digitalization and innovation in general. And this has convinced me to join a small team of people, 5 persons, that have started this Process Innovation Forum. You can see the website address on this slide. And so information is key, and obviously schedule quality contains elements of information that will determine how good a schedule is or is not, as we will see. One aspect that I would like to underline is that whatever I will say is not theoretical, is the result of a direct first-hand experience, and therefore please at least consider it real, not theoretical, and whether I will be able to convince you or not, that's something else, but I will tell you about things that I've bumped my nose against, so to speak. At the end of the webinar we'll have a short Q&A session, but maybe because of the nature of this topic it will be more appropriate to answer any questions you may have in writing via the APM. So let's dive now into the webinar itself. Oh my, oops, sorry, here it is. Okay, so the first question is, why is schedule quality important? I thought that this was the most important and kind of pole position topic because of the reality in which we are living nowadays. We are all bombarded by an unprecedented amount of stuff, of information, and we are also sometimes puzzled by contradicting information that is appearing in front of our screens. Can you just imagine what kind of dismay and sense of loss contradicting information and let's say low quality information can provide in the medical area. You know, you look for something on the internet and you find two contradicting articles, and you know, you are obviously lost and you want to know which one is of a higher quality. So the concept of quality in this world of a large amount of stuff, of high quantity, is, in my opinion, very, very important. The why element is key, as somebody said in a recent webinar I attended in Rome. There was an American professor that started his presentation mentioning the so-called law of diffusion of innovation, and he was actually mentioning a TED presentation that I suggest to watch if you are interested in this kind of stuff. It's called, the guy's name is Simon Sinek, and the whole presentation was about starting from the why. So if you're convinced that the schedule quality has some importance, you may find this this webinar interesting. This is the second webinar on this topic. The first one, which I gave in February, was of a higher level, in the sense that I kept it at high level on purpose, and I didn't dive into any kind of detail. In this case, following a request from some people, I've changed this topic in the sense that it's now much more detailed than the first webinar. I must say that this topic is rather dry. It's rather technical. We are not in the same room, so it will be challenging to keep you awake, so to speak. It is intended for a different audience. This webinar should be more interesting for people that create, you know, modify or analyze schedules from the point of view of their quality, or the quality of the schedule, because of the use that the schedule should offer, which is helping the project team to manage a project in a better way. We will deal only with some of the metrics, the so-called metrics, because the number of metrics included in this discipline is really high. Just to give you an idea, some 300 of them are included in the tool that I will refer to during the presentation. So it's a lot of stuff. And just for your information, and if you're really interested in this topic, there are other 100 plus metrics that are being defined by the DCMA, which I will define later. And tomorrow, the 28th of June, there is a webinar on the Deltec website that will describe what kind of agreements is being achieved in terms of introducing additional metrics related to the earned value management system. So one of the main challenges I had when I prepared this presentation was not what to include, but what not to include. The other aspect that is really important is that there is a lack of universal agreement on the measurement methods. What needs to be measured, what the thresholds are. These are things that are not universally recognized. I will therefore have to make a choice. I have made a choice to focus only on those metrics that I called as essential, and in particular on metrics that are pertaining to the schedule quality, not to the project performance, which in my opinion can be addressed and dealt with by means of other techniques like earn value or earn schedule. So having said what the webinar is about, I would like to put a clear frame about what will be included and not included in this webinar. So just to be 100% clear, I will talk about what is associated with the critical path method. So, forward path, backward path, this kind of stuff. And also very important, I will only talk about the deterministic approach to planning. In other words, What I will not talk about are methodologies that are, if you want, ancillary, are related to planning, and are, maybe challenging the critical path, the traditional critical path method. So no critical chain will be mentioned, no last planner, no rolling wave planning, and most important, no risk analysis. This would be obviously, or could be the subject of a webinar of its own. So just to be clear, this choice is not in any way or form related to the fact that these items that I crossed out are not important. By all means, they are very, very important. But what can you do? In an hour or less than an hour, you cannot cover all topics in a certain degree of detail. So let's talk about the core question of this, the core topic of this webinar. So schedule quality definition. This is a slide that I have kind of stolen from the previous, it's the only slide that I've stolen from the previous webinar. And this is a plain English language definition of what schedule quality is about. In my opinion, schedule quality could be defined as the quality of a schedule that provides all the main elements of information required to manage a project. As you can see, it's plain English language, nothing quantitative. I think that it's also important that the information required to manage a project is reliable. You must trust what you see, the numbers, the indicators, and traceable. So if you see a large number, a summarized indicator, you should be able to drill down and see where the data is coming from and what calculation has been made in order to achieve and produce that indicator. Another aspect that, in my opinion, is often overlooked and underestimated is that these elements of information must be promptly available. If you have to wait 2 weeks or 3 weeks or 1 month, for example, in a monthly reporting cycle, in order to get, if you have to wait for such a long time in order to get these indicators, it's a bit, it doesn't work very well. So this is, as I said, a very qualitative definition of schedule quality, which poses the question of measuring this characteristic of a schedule. If you, for example, say that the guy is running fast, unless you establish some parameters and some thresholds, the question is not, the answer is not clear. I might say that I must be of the opinion that somebody, a 100-meter runner, is fast if he can cover the distance in less than 11 seconds. If you change it to 12, it's obviously a completely different number of people. Or if you allow me to make an analogy in the world of music, which I happen to know a little bit, having studied violin for 10 years, I can assure you that if you say that he or she is a good violin player because he can play the monumental chaconne of Bach, it's substantially different than saying that he can play Happy Birthday on the violin, right? So it's very important to put some numbers against these parameters. And the last aspect of the quality of the schedule, in my opinion, is the way in which the information is structured, which should be done according to the audience the information is intended for. So if you are a project director, you need and you expect to receive a high-level summary, call it executive summary or whatever, that requires that the information is structured and organized and rolled up in a certain way. If you are a middle management individual or a detailed person, you need a completely different type of information. So the next point is diving actually into the sets. So schedule quality is measured by means of metric sets, and the ones that I have decided to include in this presentation are only 4, which I'm displaying on the screen. Acumen Fuse. Acumen is a tool that calculates schedule quality. DCMA 14-point assessment is a standard Defense Contract Management Agency 14-point assessment. There is another standard that I think is important because it's about a rather important organization, the NASA Health Check, they call it. And the last one I decided just to mention is the GAO, Government Accountability Office Guide. So these are sets of metrics that are being used to arrive at a quantitative assessment of the schedule quality. Some of these metrics sets include subsections. I will show only one. The NASA Health Check includes what they call schedule status, count of tasks and milestones, integrity indicators, constraints, which I've decided to display fully. Sorry for going fast, but it's a matter of time. So these are all the constraints that are accounted for. And the last one is the additional schedule information. So I can imagine, how confused and maybe desperate you are. This is a lot of stuff. This is a lot of indicators, a lot of numbers, and we need some clarifications, and we need to narrow down our analysis to a smaller set. So I've decided to deal only with two sets, the DCMA 14 points assessment and the Acumen Fuse. They are relatively widely used. They're recognized as a good way of assessing and measuring the schedule quality. Also in this case, one might say a lot of stuff, 14 points on the left and 9 on the right. So I've kind of identified some commonalities, some similarities. Please remember this term, not identical, similar. And this slide is showing actually what I mean. So there are 6 elements that I have, 6 metrics that I have highlighted in yellow that are similar to each other. For example, the first one on the top called logic is the same as missing logic in Acumen Fuse. The second one, leads, is called number, or is the equivalent to number 8 in the Acumen Fuse list, and so on and so on. So 6 metrics instead of a larger number, and some of them have been excluded not only because they are not common to both, let's say, schools of thoughts, but also because, in my opinion, they are less relevant to this webinar. For example, the so-called missed task, item number 11, is the number of activities that have slipped from their baseline dates. Or the 14 BEI, Baseline Execution Index, is an indicator of the efficiency with which actual work has been accomplished when measured against the baseline. These are the original definitions. In my opinion, these two items, 11 and 14, are more related to the performance of the project, how successfully the project is being delivered, rather than the quality of the schedule that should govern the time and resources control of the project. Item 10 on the left, which I will not dive into, is about the resources. How many activities have not been assigned resources? This again is a big topic. There are still many organizations that consider resource loading, a questionable matter. So we will not talk about this. So we are dealing with 6 metrics, which is a relatively short, small number, and we should be somehow relaxed and start applying the methodology. Unfortunately, as I said earlier, there are similarities. These metrics are not identical, which again could create some little amount of desperation. So let's talk about the differences. So what justifies the use of similar rather than identical? So the similarities that exist are about the applicability. Any rule that is applied, obviously, is about who you apply the rules to. So in the case of the two schools of thoughts, the For example, the Fuse approach applies to all the activities. So if you have 1,000 activity schedule, maybe made of 900 tasks and 100 milestones, whatever the case may be, Fuse analyzes all the activities. The DCMA 14-point assessment has a different approach. They deal with what they call total. I am not very happy with the term, to be very honest, but that's what they've done. And this picture should clarify hopefully what it means. So total in DCMA 14-point assessment language means activity in progress, so started but not finished, or not started at all. One might say that those are the important ones, fine, but the most important thing is that the completed tasks are not included in the analysis. The second difference that we must be very aware of is the threshold. Remember my example of the 100 meters or the violin complexity of a piece that determines what a good player is or isn't. So I've decided to display a couple of examples, the number of leads that are also known as negative lags. So the Fuse school of thought suggests that some improvement may be required up to 50% of all activities that are linked with the use of leads. If you look at the DCMA 14-point assessment, which is a US standard, so if you work for the defense, in the defense sector, you must be aware that they do not accept any leads. These are big differences, not small differences, because leads are really tricky parameters that hide some dangers. God knows what there is behind the band. If you say finish to start minus 10 or 15, God knows what will happen in those 10 or 15 days. Another example of difference in thresholds is the so-called high duration or insufficient detail, as the two schools say. Fuse adopts a relative approach, in the sense that Fuse says if you don't, if more than 5% of the activities have a duration longer than 10% of the overall project duration, then you have to do something if you have more than 5%. In terms of numbers, also the DCMA poses this limit, but the DCMA adopts an absolute approach. They say a long activity is an activity that is longer than 2 months. So the difference between these two approaches is depicted in this very simple diagram or chart, whatever we call it. For example, if we have a 4 years project containing 600 activities, Fuse says 5% of 630 activities should not be longer than 4.8 months. So obviously 4 years, 48 months, 4.8 months. DCMA also says that 30 activities should not be longer, but longer than what? Longer than 2 months. So imagine what would happen if the project would be 1 year long or whatever, 12, 14 months long. So a substantially different ratio of thresholds. So you are, either planners or project controllers, or you are dealing with schedules, many hours of your professional life. So what are the essential ingredients of the food that you're producing, so to speak? At the end of the day, after collecting information, consulting your colleagues, you produce activities, you work with dependencies, you work with lags and leads, if you so decide to do. You may introduce some constraints. You have to take into account different calendars, working period versus non-working periods, and last but not least, resources. So again, all these things are, many items. So I had to make another choice here, and I had to decide to focus on some of the elements the essential elements of a schedule. So let's look at the first one, the dependencies. So the dependencies analysis is about two aspects. One is if all the correct dependencies exist or not. This is obviously the well-known open-ends concept, which is also including a relatively less known type of missing logic, open start and open finish, which I will describe later. So the thresholds for DCMA and Fuse is the same, 5%. And the other aspect of the dependencies that the metrics scores include are what types of dependencies are in use. As you know, there are 4 types, and the Fuse and DCMA threshold is again greater than 90%. Finish to start should be greater than 90%. Now, I have decided to include some really simple examples. Forgive me, I don't mean to be offensive to your knowledge and expertise and experience, but I wanted to show you some, let's call it logically correct schedule. So this is a very simple schedule that I built for the purpose of this webinar. 3 buildings, a fully linked schedule, the only 2 open ends, no predecessor on the project start and no successor or the project end, generate a very clean critical path that can be seen on the right-hand side graphically and on the left-hand side, on the tabular side, in terms of numbers. Total float 0, and project building B and building C have some float. So this is one extreme, a fully linked schedule. There are situations in which a schedule may be apparently incorrect. In the sense that, for example, a project B, which or a subset of project B, these 3 activities may be considered open-ended. The top bar doesn't have a predecessor, and the top and the bottom milestone doesn't have a successor. But maybe there is a project A that has a milestone in it that leads into project B. These are so-called interfaces, inter-project relationships. Project B, the project B milestone may be actually the one that is pushing the first activity of a project C, right? So we have to be careful before defining an open end. Now, I've decided to include also a couple of slides on the so-called open start, which is not as frequently identified as the so-called open end. So an open start is a situation where 2 activities are linked with one relationship only of the finish to finish type, usually accompanied by a lag, in this case 10 days. The problem with this method of working is that the successor, the green bar's duration, can be extended and actually be extended to the data date without affecting the project critical path. This is quite serious. On the other side, the open finish, which is including the use of start only, so this is the only relationship that exists in between these 2 activities, also in this case very often associated with the introduction of a lag, 10 days. In this case, the predecessors, the blue bar duration, can be extended to the project finish date without affecting the critical path of the project. So to say the least, this is not very good. Okay, let's say it's a contribution to low quality. In terms of what kind of dependencies, so you remember I said what exists or what doesn't exist and what type of relationships are in use. This is a very big topic. I will just mention it. There is still a wide and sometimes hot debate about what kind of dependencies should be used. In my opinion, I take the risk of exposing myself. I come from the finish to start school of thoughts, especially when the program is consisting of relatively detailed activities. So introducing lags and leads is, in my opinion, not a very good practice. Last but not least is that if you do use legs and leads, you have to take care also of the calendar of the legs and leads, and you may generate other situations of confusion that I will show later. So when we talk, or when a conversation takes place about finish to start rather than start, finish, dependencies type, usually the concept of legs and leads is discussed at the same time, because you will rarely see start with no leg or finish with no leg. So this is another complication, which if you add the further complication of activity types and dependencies types, makes this topic really, complicated. I have included the slide here, which depicts the possible combinations between types of dependencies, types of activities, the use of leg and lead. If you think of how many combinations there are, you may have a start milestone linked to a task with the leg or the lead. It becomes really complicated. I repeat, I am not ashamed of saying that I come from the finish to start school of thought. If you think that whenever a bar chart is drawn on a piece of paper, as an example, everybody draws activities following each other, i.e. finish to start. So I just wanted to underline some of the impacts of an improper use of the dependencies. This is a classic, you must have seen it. I would like to remind you, this is experience, this is not theory. The successor's activity is artificially delayed by the introduction of a lag between the milestone leading into it and the bar. Then there are situations where tasks are linked with the use of lag in between. The classic justification for this is that the lag is actually representing, for example, concrete curing. So my question is, why not defining an activity called concrete curing? And if this happens to be the critical path, one would understand why these three activities are critical. Last but not least, again, you may think that I am a pessimist or that I'm displaying stuff that is unreal. This is the use of lead, between two activities. So when the critical path is challenged because, for example, of a delay of an activity, some planners try to recover or to stay within the allocated period of time by introducing leads, finish to start minus. Unfortunately, this practice may lead to the introduction of a lead, finish to start, for example, minus 20, which could force the successor to start before the beginning of the predecessor, which is also rather odd. So the other element that I have decided to include, and I selected for this presentation, is the topic of constraints. Now, we all know that the use of constraint is to influence and control what the critical path method does, in terms of dates, early and late days and total float, right? So I have decided to jokingly call the critical path Mrs. Critical Path and Mr. Constraint are fighting with each other. They are fighting because Mr. Constraint would like to prevent the schedule from being driven by the logic. Now, there are, thanks God, there are different levels of constraints or constraints that are stronger than others. The terms actually in use are hard and soft, as you know. Hard constraints are those that have really got some power that is winning in this fight with the critical path method. I have decided to represent a constraint with a big nail And if you apply a constraint, in this case, to a milestone, what happens if the sequence of activity is not actually performed? You know, the critical path method, the forward path, will push the tasks, and the milestone will be kept in place by this big nail. Now, one might say, okay, if I look at the bar, I can see that there is a problem, and something will be done about it. I am thinking of a situation which is not unusual. I'm thinking of a situation where the progress reporting system is heavily dependent on milestones. You know, some project managers, also because they have, they have a limited amount of time, ask for a reporting system that includes only milestones. Now, can you imagine seeing a milestone which has always got the same date and the same float? In this case, total float equals 0. You know, the project manager might say, okay, I know this milestone is critical, no problem. I've known it for the past 6 months or whatever. You know, this hard constraint will not start the alarm bell that should be started if the critical path is threatened. The second family of constraints is the so-called soft constraints. So this, the one I've used as an example is the mandatory finish. The soft constraints, a family of less powerful constraints, which I've decided to draw using a pin rather than a big nail, behave differently. So what happens if a sequence is delayed? In this case, if we apply a finish on constraint, the term finish on, is quite strong, but it's not as strong as mandatory. If you apply a finish on constraint, and if the activities leading into this milestone, in this case, have not happened for whatever reason, at least in this case, the milestone will move. So the date will change, and the same manager I was referring to earlier will actually see that the forecast completion date of this milestone has changed as a result of a delay. Okay, so this is much less dangerous than a hard constraint. So the main differences between the constraints are the terminology and the family they belong to, hard and soft, and also the way in which they work. So we must be very clear about the effect that the constraints have on the float, on the total float in particular, which is obviously what determines the critical path and the criticality, and also the dates, the way in which the constraints affect the dates. These are the key elements that must be taken into account before making any judgment on the schedule quality. So in terms of schedule quality, quantitative schedule quality, I have summarized on this screen what Primavera says, and how Primavera classifies the constraints. So mandatory start and mandatory finish are those that, in my opinion, should never be used because they just generate misleading messages. If we look at the Fuse schedule quality index, what Fuse considers hard are the mandatory finish and also the must finish on. Please be careful, not finish on. Must finish on and must start on, which, by the way, is Microsoft's project language. Okay, the DCMA original documentation considers hard constraints, the ones that you can see in orange on the screen. Now, I must say this is not exactly super clear. So we have to be really careful on what the constraint that we may decide to apply, what it is and how it works. Also because the metrics, the number that determines the the quantitative assessment of the schedule will be determined by the choice of one constraint type rather than the other. It's the terminology is very important. It's like saying, what I'm showing on the screen here at the bottom, that these two words or these two sets of words are the same. I hope that Mrs. May will not be angry with me for using this thing that I found on an Italian newspaper. So I have decided to include a couple of examples just to convey the messages that I've talked about in a more realistic manner. This is a real example taken from one of the sample projects that come with Primavera. When you buy Primavera, you have the option of installing also this sample project. What I've done, I have taken the sample project as it is, and I have decided to display only the critical path. Okay, so as you may see, I don't know if you can see it from where you are, but there are 22 activities, the activity count, 22 activities, and the project end date, you may see the date is the 12th of July 2013. Now, I have broken on purpose one of the dependencies, and the result is shown at the bottom of the slide. Now, the new project finish date, 26th of February 13, is substantially earlier than the project finish date of the original schedule. Now, what is the message here? The message is that one broken relationship, on a total of 93, so the modified schedule has 92 dependencies, whereas the original one had 93. So a 1.08% difference is causing an 18% difference in project duration. So 517, the original schedule, 422 days, the modified schedule, 95 days of difference. Would anybody like to be the project manager where the modified schedule is the baseline? I wouldn't. The second example that I would like to offer to you, at the bottom of the screen you see 6 missing logics, 6 open ends. Now the interesting bit is that the worst schedule has a higher score. Now this is due to the other metrics that contribute to the overall value of the score. The DCMA 14-point assessment, look at it, is really interesting because the original sample project gets a 45% score. The modified one acquires a 69%, and this is due again to other factors that contribute in a weighted manner to the definition of the score. In addition to a schedule that may be considered unimportant because it's part of a a software house example, an example produced by a software house, I've decided to show you a real world example. Obviously, I will not disclose the nature of the project nor the client, but this is a schedule that I was asked to analyze a few days ago, and I would like to show you the results. Now, this is not a small schedule, 1,000 plus activities. I won't say more than that, but look at the score. This the top ribbon is the Fuse score, 70%, and the bottom one is the DCMA. Now, what conclusions can we draw from this? We can say that there is a substantial difference in value of the scoring system, that there is an obvious systematic use of lags. I don't know if you can read it, 289, actually this means activities linked with a lag, and the number of lags is actually 511, and there is also a systematic use of relationships that are different from finish to start. I don't know if you can read, 685 start and finish. I have recommended my client not to consider this a good schedule and turn it into the baseline, and that there is a substantial amount of work required to improve this schedule. So the risk of executing the work according to this type of quality, low quality in my opinion, is very, very high. So maybe we should now draw some conclusions. What, and of course we need an expert assessment in order to judge these results. So what is really important when we are involved in a schedule quality assessment, quantitative schedule quality assessment exercise? We must be really careful about what we do. If we take a single, even if it is a sharp and strong element, we may make a really big mistake. We should look at more parameters, which will make this much less painful, and ideally we should look at all of them that are appropriate in this environment, and therefore we could draw some wiser conclusions. Okay, so the numbers are given by computer software, whatever manual count, whatever you want to do, but you have to be very careful about how to utilize these numbers. So I'm now going to some conclusions that I actually hope will be what you take away with you. The majority of the metrics that you will see in the literature and in the applications of schedule quality quantitative assessment are about counting what is missing or counting what exists of the wrong type. Now, I would not question this. I wouldn't spend any much, more thoughts about this, because this is something that computers do very well. So I would just suggest to look at them, verify which ones are really important, and do whatever is necessary. The important thing is that we must be aware that what exists in the schedule may be the problem. Using a very, very extreme example, a schedule may be perfect. It may acquire, I don't know, 100% score on both systems, but the dependencies may be wrong because the planner, I don't know, was not helped adequately by the team, or just because the dependencies are wrong. So please be aware of what exists, not only of what does not exist. The 80-20 rule is something that I have decided to include because I have found myself in situations where I discuss this principle, sometimes with important people. Again, obviously I cannot mention their names, but there has been several situations in which the debate of the 80-20 rule was, went on for a long time. The question is, if a schedule acquires a high score, say for example 70%, is it really worthwhile investing time and money in making good the remaining part of the schedule? I believe that also in this case one has to be very careful, because not addressing that 20%, so to speak, may really be catastrophic. It's like saying that if you are talking to an accountant and he's supposed to add up 10 numbers, and it's like saying, okay, it's 8 of them is enough, it's 80%, or 9 of them is also even better, 90%. There are disciplines, there are calculations that require a careful attention of what you do and how you do it. The other point that is very important for me, for you to take away as an advice from me, is that there are elements of the schedule that are not included in the tools that I know of, that are heavily responsible for schedule quality. I am referring in particular about the elements that make a schedule clearer, that make the communication of the schedule better. So I'm referring, for example, to the design of the WBS. The WBS design, in my experience, may make a huge change. If the WBS is well designed, the team will understand the schedule, and the schedule may actually be tabled. We all know that schedules are not very often, or not sufficiently often, tabled at meetings. If the WBS is well designed, it's very easy to understand a rolled up view of the schedule. I have created WBSs of a very large number of activities which are, very easily understood by anybody. It takes 5 minutes to explain what the project is about. The other element that is not included in schedule quality assessment tools is the coding system. What I mean is the following, even if you have an excellent WBS, there may be situations, and it happens very frequently, where some stakeholders, some managers, some shareholder, whatever, will ask for a view that is different from the WBS. This can only be done by coding, by a coding system, which, by the way, serve also other purposes. You can create some really surgically precise filters and summarizations. What I'm trying to say is that I don't think that it is possible for a tool, unless we develop artificial intelligence to a degree that is not yet there. I think that this is still something that a planner should do together with his project team. The second page of conclusions, we are nearly there, is about what I said at the beginning. We do not have, as you've seen, I've given you some example, there is no universally recognized method for measuring in a quantitative manner the schedule quality, and therefore we have to wait. I don't know when this will happen. It's beyond our control. If a standard exists like DCMA, fine, but if it's not recognized worldwide or whatever within a continent, it's a problem that I cannot solve. We just have to be aware of this. An organization that is serious about planning should therefore establish its own rules and limits. For example, if an organization believes in logic, they should focus on open ends, avoidance of use of hard constraints, and so on. So it's really important to make a choice. The other schedule, the importance of the schedule. There are blogs around that question the need for a schedule. I think that instead of questioning the need for something that I believe is required when there is work involving interfaces with other people, many organizations working with each other, I think that a schedule, a plan is required, and therefore the effort should be devoted to making it better rather than trying to convince anybody that a schedule is not required. And last but absolutely not least, the schedule quality is can only be achieved when two ingredients are there, and I put the experienced planner first, and the second one is smart tools. So I would suggest not to invest a lot of money in the tools unless you have at least a core team or somebody that can utilize this tool and judge the results that come out of these tools. So my recommendations is addressed especially to those of you that produce the schedule. Please contribute to the success of the project. Do not hide anything that you may know about and that you think that is a good idea to hide, because sooner or later it will it will become visible. If you keep doing a good job, I think you will be sooner or later respected. And last but absolutely not least, it's going to be greater fun to develop a high quality schedule. And with this, I have finished my webinar, hoping that there are still some people listening. I pass the word to the APM office.
Thank you very much indeed, Franco. We are having one or two questions that are coming in, if you're able to just give a quick response. The first one from Ashok is, do you manually develop the stats or run it via a tool to get the DCMA and other assessment comparisons?
I use a tool. I use Acumen Fuse, which is a tool that comes with the built-in DCMA point assessment methodology, And some of the metrics, of course, can be also done manually by exporting activities from the planning software that is in use, like Primavera or Microsoft Project or Asta Power Project. But in my personal case, I use a tool. It's faster, much faster.
And probably linked onto that, there's been a question about using MS Project and what's the easiest way or tool to assess the quality of my project.
Okay, again, there are tools around, and my preferred one is Fuse. I don't have any shares of Deltek, but I think it's still the best tool around, even if it is not exactly super cheap, I must say. Fuse reads also Microsoft Project, and therefore if any organization has chosen a Microsoft Project as their planning platform, they can analyze their projects, their schedules with a tool like Fuse, and they can carry out the Acumen Fuse index analysis. They can do the DCMA, and they can also develop their own bespoke set of metrics, which is what I said in my slides. If an organization is not happy with the existing schools of thoughts, they can develop their own, and they can include only their metrics, and therefore the result of the analysis will be particularly meaningful to that organization that has developed its own set of metrics.
Thank you very much indeed. It's been a very informative and I hope helpful webinar and presentation from yourself. So thank you very much. On behalf of APM Planning, Monitoring and Control SIG Specific Interest Group, we would just like to thank you for your time as a second webinar, and I know that a few more questions are coming in. Just with the time, what we'll do is you've very kindly agreed to answer some of these questions, and we will make that available as a write-up page on the microsite area of the APM website. So that's the Planning, Monitoring and Control SIG microsite page of APM website shortly. Thank you very much, Franco, and thank you.
No problem, and I wish you all a good afternoon. Goodbye. Goodbye.